Morning folks, and welcome to the surgery of the WTF. In resus bay number 1 we have a 70-year-old patient known as Mr. WS52 set, who presents in a rather extremist condition with acute diode detector failure. He has extensive comorbidities, including widespread decoupling capacitor failure, acute crystal calibrator failure, and in being in a rather general state of poor health and generally out of tune. So what we're going to do, we're going to send this patient to theatre. We are going to perform several surgeries to try and bring this poor 78-year-old patient back to life, and yeah, we're going to give you some live coverage of the surgical procedure that we've got in mind. So with that, we will show you the innards of this individual, the giblets, and hopefully bring the old beast back to life again. So enough of the doctor nonsense. So here's the 52 set. Just for those who are not familiar with the wireless set 52, there were well, this receiver is part of the wireless 52 set. Well, originally there was two of these type of receivers. There's a wireless set 52 remote, which is what this is, a remote receiver, and then there's another. Then the same type of receiver would also partner the wireless set 52 transmitter, which seem to be quite difficult to get hold of. Those are actually quite nice transmitters because I think they've got an 813 in the final, so they're quite pokey transmitters, and I think they're quite sought after. But the receivers, these receivers are quite, they're relatively easy to get hold of. I've got two of these now. This one's been sitting on the shelf of shame for a good few months, and I think I fired it up once and it didn't work, so I sort of stuck it on the shelf and forgot about it. So the last couple of days I decided I would take this off the shelf and see if I could get it to work. And there was a couple of minor faults with it, nothing too difficult. And hopefully I'll give you a bit of a demonstration. I've managed to get it working, and it seems to work quite well actually. Just to run through it, if you're not familiar with it, I'll just see if we can zoom in a little bit. So we'll start at the top there. So you've got, just coming a bit more. So at the top there you've got a crystal calibrator, which does it in several notches, 10, 100, 1000 hertz. But this, or KCs I should say, it's not really that. I don't think that's working. There's about 3 metal valves which are controlling that, but it's not essential. But it doesn't, from what I can tell, doesn't appear to work. It's in quite good condition actually for its age. I wonder if we can zoom in on that data plate there. You can probably just about read that. I'll bring the camera a little bit closer. So this was manufactured in 1944, so it's 78 years old. Not too bad really for something from World War II. And I'll just zoom out a little bit more. So you've got aerial input there, you've got a frequency adjust, which is like a vernier type thing, and the main tuning is there. So it's got 3-band coverage, and we'll have another look at that. We've got 1.75 to 4 megs, 3.5 to 8, and 7 to 16. And those of you familiar with the 19 set will recognise that sort of dial, which is very common 19 sets, 62 sets, things like that. You've got general meter there. It's got some filtering, sharp and flat, and then you've got a multi switch or multiple position rotary switch there, which basically looks at the cathode voltages of all the various valves, which is quite handy. I'm not quite sure how accurate this meter is though, so I think you can probably look into that. And then it'll do CW and AM, and it will actually receive SSB actually, as we'll see later. So it's quite nice, quite a nice receiver actually for what it is. And it's got, this one has got its own power supply. The power supplies are often a bit tricky to find with the receiver, but this one's actually got the power supply. Now this power supply, I'm not going to show you the inside. There's not really much to see. It's all got the original components in, and when I took the back off it, which has got about 9 or 12 screws, it's a little bit of a mission to take off. But anyway, underneath all the components are there, and the components actually look in very good condition. And from what I understand, this power supply had a vibrator unit, so it could run off 12 volts, or you can run it off the mains, which is quite handy. And the voltages required for this are actually fairly easy. You know, it's 150 volts. It will actually work on a slightly lower voltage, and it works quite well. And 12 volts, 12 to 13 volts for the LT supply. So there we go. It's quite a nice vintage World War II receiver. So what I'll do is I'll just show you some of the things that I've done on this receiver to get it working again. Before I turn it over, I'll just show you some of the innards of this. So most of the valves are AFP34s, I think, pentodes, and it's got a couple of metal valves there for the crystal calibrator. Most of the valves are in these screening cans, and when I first started work on this receiver, the first thing I had to do was take all these screening cans off, and give them a good clean up because they were all quite rusted. So they're actually looking a little bit better condition than what they are at the moment. So I'm just going to roll it over onto its front, and you can have a look at the rest of it. So this is the underside of the receiver, and as you can see, I've actually replaced a lot of the capacitors. Most of the capacitors that I've taken out are in this box, and most of these are these foil type capacitors. Now some people say these don't usually give much trouble, but if you're looking at capacitors that are 80 years old, almost 80 years old, then I'm not so sure. These are actually this box I tend to put all these sort of Sprague vintage capacitors in. Some people say they don't, you know, they're quite resilient to leaking, but I have to admit that when I was sort of going through this and replacing some components, there was an electrolytic there which almost certainly would have been DOF. So I've replaced it. I've replaced that, and you can see I've put in some sort of modern polymer type capacitors. Most of them were 0.1s, decoupling capacitors. And so once I did that, this thing worked quite well. The other main problem with it as well, when I initially fired it up, it was pretty well dead. The detector valve was not working, which was, I think the filament was open circuit, so I had to buy another one of those. But you can see the sort of typical wiring looms of 1940s World War II equipment. A lot of the wiring is done like that, you know, it's all hand bound up, and these wires, funnily enough, are, you know, very resilient. They really do stand the test of time. I haven't really done anything to the wiring on this rig. I've literally just replaced the capacitors. There were a few resistors that were quite high, especially the 1 mega ohm ones. Some of those were really high. Generally, with valve equipment, the resistors, you know, if they're a bit out, you don't have to worry too much. The thing will probably still work. But when you've got, you know, some really high values, it's usually best to replace them. And on this side as well, just moving around, I hope you can see that. There's more boards where I've replaced the capacitors. I was toying with the idea whether to realign this thing completely, but as you can see, these are the trimmers for the IFs. They have like two sets of trimmers, sharp and flat, and apparently, although it is doable, but once I'd replaced all the capacitors on this, the thing seems to work reasonably well. So I decided, well, I'm not really going to fiddle with it too much. But it is doable, and apparently you can peak them. You know, if you can adjust the IF response and peak it up, and it will probably improve the performance of the receiver. But as I said, testing it now, and it seems to work quite well without having to be you know, completely realigned. Anyway, let's give you a quick demo of this. We'll listen to some AM, and we'll listen to some SSB just to show that it does receive quite well. This 52 set was quite deaf originally, but since I've recapped it, it sounds pretty good. And I'll just turn up the RF gain.
G6 TVJ returning. I'm in a break station there. Just to have a little listen for a break station. For a station there, go ahead. Okay there, Bob. I've got you. I've frantically written you down, so I'm terrible for forgetting. And let me just have a listen to my inverters. Yeah, they're okay. They're both running.
That sounds pretty good, actually. That's on AM, obviously.
Bob, it's kind of lighting conditions this morning, but both you okay on the call in there, so I guess you're between about 5 and 10 over 9, so I shall hopefully endeavour to pass it to you very shortly, but not sounding too bad. Hope you're well down there in Cornwall there, Bob. Okay there, Ken, the ART13 sounding pretty good into Bristol. I didn't think you were far off frequency-wise. I didn't put my synchronous on, but anyway, I don't think you were far off frequency-wise this morning. Thanks for the signal reports. I'm on this crazy Sailor T126, so it's upper sideband reinserted carrier. No, actually, I think it's lower sideband. I've got the crystals in it, I think the wrong way round. It's got two positions. It's a crystal thing, basically, and so I think I'm actually lower sideband currently with reinserted carrier, but my normal homebrew transmitter blew up yesterday. I've been away working with a day job, so I've been off the air for quite some time, and I put my transmitter on yesterday, and one of the electricity capacitors popped on a little cloud of smoke, so some of the smoke has escaped from a 220 mic 450 volt cap, but it's my own fault. I've been running them sort of close to the edge. I've got two in series, and the 80 volts are about 900 volts. It's a marginal design, a marginal TVJ design, and the electricity can have enough. So I'd have to modify. I'll put 3 in series and give myself a bit of headroom with the working voltage with those electrolytics. But there we are. What else can I report? Yeah, I'm missing some of the SDRs. The Western SDR is still off the air.
So we've got a SSB station here, and it's quite interesting actually, because bear in mind that when this rig was built, SSB hadn't really been, well, it was in its infancy. It probably hadn't even really been invented. Most people were using AM. But you can receive SSB quite well, and we've got quite a strong station here on frequency. I find that to tune SSB, it's easy just to twiddle the frequency, the fine frequency adjust.
What's the latest version of Thetis for it? But you may well be right. I'm sure you're right. It's probably slightly different. I know it only carries up to, I think, 34 megs. I think it does 160 kcs up to 34 megs. So it doesn't go as high as 6 meters. Somebody has done a hardware model, I think, to cover 6, but I'm not really interested in that. I was more interested in just having a play with Thetis and, well, possibly looking at it as a transverter driver, possibly.
Let's see if there's any other stations. You can actually resolve SSB quite easily with this. I'm quite surprised, because SSB can be quite tricky sometimes with old school receivers. That's Jeff, GW2 He's not far from me. He's in Cardiff. He's often on one or two of these nets on Sunday morning. Anyway, I think that gives a reasonably good demonstration. Anyway, it's a nice old World War II receiver. And what I'm going to do is I'm going to fabricate a box for it. And I've managed to track down the colour code of the receiver box, which is, for those who might have a similar receiver, is RAUL 6021, and I got that information from Martin G3YJO on the VMARS net, which was quite helpful. So we're going to make up a box for it, and we're going to send our patient out of theatre to recovery, and hopefully use him all the time. He's a good old boy. Anyway, thanks for watching. See you again soon.